Welcome everyone. Today's webinar is introducing a new metric to show efficacy of organ preservation solutions. Just a little bit of housekeeping. In order to collect your Category 1 CEU from today, we ask that you stay logged in for the entire duration of the session, or at least 45 minutes. And also there will be a webinar at the post-webinar survey at the end. We ask that you complete that survey and you submit that. Once you submit that, everything is complete and you should receive a CEU certificate from SpecialtyCare within 1 week's time. This session will also be recorded and put on YouTube for viewing availability post-webinar. This is what the webinar looks like at the end. As you can see, it's just a few questions, so it should only take you a minute or two to fill out. And again, you need to do that in order for us to be able to send you the CEU certificate. And then once Bill is finished presenting, or throughout, if you'd like, if a question comes to you, go ahead and put it in the Q&A window. I'll be able to see them. Bill will as well, but I'll be paying attention to them. If you have a question that is similar to someone else's that is already there, go ahead and vote on that question, and that will help that question move to the top so I can prioritize that in getting those questions over to Bill to answer. And finally, our presenter this evening is Bill Nicotra. Bill is the executive director at Custodial Pharmaceuticals. Bill is the medical science liaison for Custodial HTK and a practicing perfusionist for 39 years. Some of his achievements include designing and utilization of the first ever ex vivo lung perfusion circuit in the United States. He was chief perfusionist at UNC Chapel Hill, Temple University, and MedStar Union Memorial in Baltimore. He's also been president of North Carolina and Maryland Perfusion Societies, still volunteers for mission trips around the world, and is a board of director for CardioStart International. He's the executive director, again, of Cardiac for Essential Pharmaceuticals, and he is as excited as we are to present for us today. So I'm going to stop sharing and turn over the controls to Bill.
Awesome. With that introduction, that's a large billing to live up to. So hopefully you guys will be as excited as I am about what I'm sharing here today. Let me get this. Okay, and can you confirm that you can see my screen?
Yes, you're good, Bill.
Okay, good. Awesome. All right. Well, again, yes, I'm here to talk to you today about a new metric to show efficacy in organ preservation solutions. My disclosure is obvious and it was stated by Karen eloquently. And by the way, thank you, Karen, for all the work you've done to get this presentation off the ground and to get and provide this platform for me to share this information. I really appreciate it. So I am the MSL for Custodial and for Essential Pharmaceuticals. And if you're new to that term, Essential Pharmaceuticals, we're the distributor of Custodial HTK in the United States. We're not the manufacturer of the solution, so just wanted to make that distinction. And obviously, I'm talking to you today as a clinician and sharing some clinical viewpoints. And so why we're here today, because typically whenever we looked at studies to determine, efficacy in cardiac surgery or in transplantation or any surgery, the traditional ways to measure the effect of any change that we made was typical. It was looking at, post-operative outcome data. And the typical markers that we were all accustomed to looking at was how did what we were doing influence ventilator times, the amount of blood products utilized, the needs for inotropic and or mechanical support, length of stay, mortality. But in the transplant world, we're looking at the primary graft dysfunction or, failure of that particular organ to function post-transplant. So those were the typical outcome data that we're all used to seeing in studies looking at changes. But today I wanted to talk about what's happening in the medical field and looking at a new way to kind of prove efficacy of what we're doing and looking at individual solutions and how they affect the actual outcomes of the different transplants. And so today I'm focusing on what are the effects of the solutions that we utilize during cardiac and organ transplantation and how they affect protecting the mitochondria, because we know how important the functionality of the mitochondria is post reperfusion of the organ. So that's why we're doing it. But the whole medical field understands that we need to get to the root of what the solutions, in particular, what I'm talking about today, or techniques that we're doing, how they affect the mitochondria, and come up with a consensus of which type of application has the greatest effect on the mitochondria. So, and I took a quick screenshot. When you look at clinical trials, you can see that there are a lot of clinical trials focusing on just this topic. And the topic is, you can see in the fourth column, the effects of solutions on the mitochondria and how it affects it. And so this was just a screenshot, but it's definitely something that we're seeing in a lot of the early studies is kind of looking at getting it down to the mitochondrial level and looking at efficacy from that level. And so when I did a lit search about this particular topic, I found a few from each of the organs. When I looked at articles about kidney transplantation, I came across this nice paper by Lou and the group. And this is looking at targeting the mitochondria during cold storage in transplantation for kidney transplants. And what I really liked about this particular article and paper is that they did a great job of explaining in detail what happens during to the mitochondria in the kidneys during cold ischemia. And you can see what happens to the mitochondria during that cold storage. We're losing ATP, we're increasing the reactive oxygen species, and we're increasing a lot of the inflammatory markers that you see there. And so this is happening during the cold storage transportation of the kidney. And then once implanted during the reperfusion, you can see that the effects of the ischemic reperfusion injury doubles that effect. You can see that twice as much ATP is lost and so many more reactive oxygen species are generated, as well as inflammation markers that you can see. And what does that lead to at the very end? Renal dysfunction and could lead to the primary graft dysfunction. So this did a really good job of showing this is what happens in the kidneys from a cellular level, looking at the mitochondria. And so later in that same paper, again, it's showing you during the cold storage is that there is that mitochondrial dysfunction. And then during transplantation, the increase of that dysfunction. And then during reperfusion, you get mitochondrial dysfunction leading to renal damage. And so they ask, is there a solution to this particular problem at hand? And in concluding, it says that basically it's a great time to look at it, and there can be therapeutic interventions that can mitigate the mitochondrial injury and damage that happens during cold preservation of the organs. And so it's something that should be followed and studied more closely. So then I included a second paper in the kidney transplant search, and this paper was very supportive by Karosh and their group. And they basically explained in this article how the mitochondria contributes to primary graft dysfunction. And again, you can see that ischemia really has an effect on the level of ATP available. And then throughout that ischemic process, it leads to that decrease in the ATP ADP ratio, which obviously causes cellular necrosis. And we see that the mitochondria are so essential in reperfusion injury and generating the what happens in the reactive oxygen species that it's being generated during that injury, and having that mitochondria there to abate that is very important. And they put a table in this particular article, which I wanted to show to you today, because in the top table, you can see that the effects of the reperfusion injury on the heart during the acute phase has a 30 increase in 30-day mortality and early graft dysfunction. And late, it has the increased mortality of the 1, 5, and 15-year survival rate. So it really has plays a significant role in the success of the transplant. And this article, they mentioned that this is a great time to start looking at transplantation from the mitochondrial and metabolic perspective. So it's something that's being talked about. And later in this summary, you can see that maybe there are new pharmacological interventions and changes in clinical practice that could be applied to improve how well we protect the mitochondria. And then I also wanted to just at least include one of the papers about liver transplantation. And so I found this paper by Machado and their group. And again, they do a terrific job of, again, mentioning what's happening to the mitochondria during the ischemic process and during reperfusion, what the effects of reperfusion injury is. And basically the same thing is being played out in this article. The increase in the reactive oxygen species happens, which leads to a decrease in the amount of ATP available, and you get cellular necrosis, and that could lead to early graft dysfunction. And again, their concluding remarks, just like the previous paper, very supportive. It's a great time to look at transplantation from a mitochondrial and metabolic perspective, and that we definitely need a better understanding of how these metabolic contributions play to transplants and could lead to new pharmacological interventions, like I said in the previous article. So these articles are very complementary and support the fact that we can influence the outcome of a successful transplantation by perhaps changing the pharmacology that we utilize during the process. So that leads me into the main portion of the topic today. Excuse me. So I'm going to talk about protecting the cardiac mitochondria. And in 2020, and I know that I've been with Essential Pharmaceuticals for 7 years now, so I know that if you've seen me speak in the past, I was very high on this particular study, and I still am. And it was far in advance in its time when they decided to put out this particular study. But this is a study by Gneiden and McCusker and their team. And they set out to look at all the different cardioplegic solutions that were available and how they affect endothelial cells in cardiac surgery, utilizing the different cardioplegic modalities available. So that was way ahead of its time whenever this was first put out there. And if you recall, they looked at primary neonatal sites as well as adult endothelial cells, looking at St. Thomas, blood cardioplegia, custodial, HTK, and Del Nido. And when they looked at this particular cell culture, they looked at the viability of the endothelial cells as a whole. And you could see at the 2-hour mark in this particular study that all the cardioplegic modalities basically did a decent job of preserving the viability of the endothelial cells. And at the 6-hour mark, still very similar. But when you get to the 24 and 48-hour mark, when they did sampling, you can see a distinct difference between the custodial HTK and the purple bar group as compared to its cohorts of the Del Nido, the blood cardioplasia, and Plegiosol. So a significant difference in the viability of the particular cells. And I'm a visual learner, and this speaks volumes to me. If you recall seeing this particular slide, when you look at the custodial controlled tested group, I'm sorry, at the 24 and 48-hour mark, the bright green, vibrant cells are significantly different than its counterparts of Del Nido, St. Thomas, and blood cardioplegia. And I threw this in here too because this was part of the study, and I thought it was an important thing to mention, and I've talked about this in the past. When you look at primary neonatal cells, you can, at the 2 and 6 hour mark, very similar in testing the viability of the cardiomyocytes. But when you get to the 24 and 48-hour mark, actually the Del Nido cardioplegia original formulary was very comparable to the custodial HTK group, which to me supports the solution developed and utilized in pediatric surgery for quite some time before it was adopted in cardiac surgery. But again, you can see very different from the results that you see in the adult endothelial cells versus the pediatric cardiomyocytes. So, and again, this is Gneiden's work. He is, like I said, very ahead of his time in understanding what the medical field, where it's headed, and how he can contribute to the overall science. And so he did a study last year looking at the long-acting or single-dose cardioplegia techniques and how they affect the mitochondria. And the reason he did that is because, like the literature that I showed previously, he understood how important that the mitochondria is in preserving the heart and generating the appropriate amount of ATP required when the heart is reperfused, and really what the role of ischemic reperfusion injury can be, and that looking at the mitochondria is an extremely important marker for viability or cardioprotection. So he did this particular study looking at Del Nido and custodial HTK. And so in an in vitro controlled study, he tried to mimic a typical minimally invasive case, taking an 80-kilogram patient and utilizing that weight of a patient, he could approximate the appropriate amount of cell count to study and to preserve in the different wells of the study. And so he had three groups. The group number one was the endothelial cells that were preserved with custodial HTK. The second group was preserved by Del Nido cardioplegia. And then the third was the control group, or the freshly harvested. And so you can see at the bottom there in the arrow, this is how he mimicked an actual case. So at baseline, like going on bypass, he measured the endothelial cells at 36 degrees centigrade, and that was the control. And then cooled to 32 degrees, and at the 90-minute mark, took a sample, and then rewarmed the patient, and then, or the samples, but mimicking a patient, rewarmed back up to 36 degrees, and then at the 6 hour mark, wanted to take a look at the cell cultures he sampled. And basically, when he sampled them, he wanted to look at mitochondrial functionality and viability. And here's where the results of this particular study. And if you look at the top left table, you can see the percentage, and this is at the 6 hour mark, you can see the percentage of necrotic cells that each of the groups had. And in the control, so this is just freshly harvested endothelial cells, the percentage of necrotic mitochondria was 1%. And then compared to the custodial preserved at 6 hours, it's 1.2%. So almost dead on baseline. But when you look at the Del Nido control group at 6 hours sampled, you're looking at 4.8% cellular necrosis, so significantly higher amount of the mitochondria being necrotic. And then you get over to the tables to the right, the mito tracker green percentage and the mito tracker red percentage. The green percentage is basically looking at the functionality of the mitochondria. So how functional are these mitochondria that are sampled at the 6-hour mark? And at the control group, it's 99%. In the HTK group, custodial HTK, again, 99%. So it was exactly equal and pretty close in the Del Nido group at 90.5%. So almost 91% functionality of the mitochondria at 6 hours. So fairly similar. But when you look at the mito tracker red, that's an indication of the long-term protection or how the survivability of the mitochondria will be after the 6-hour mark. So how functional and survivable will they be later on? And that's what this particular test. And you can see in the control, it's at 98.5%. And in the custodial, it's at 99%. So at 6 hours, it's more likely that these mitochondria that are harvested and protected are going to be more functional and viable at the 6 hour compared to you look at the Del Nido and it's at 60%, significantly lower long-term survivability of those particular endothelial cells long term. And again, this is an in vitro study. It's not clinical. So how that relates to clinical is yet to be seen. But again, this is early work, and that's why I said it's very important work that it's being done right now. And here's just a recap of everything that I said, with the exception of which was not shown in any of the graphs, the late apoptosis. So it was only 0.7% in the custodial versus 5% in the Del Nido as compared to control of just 0.5. So again, the custodial and the control are extremely similar in late apoptosis. And again, I love visual expressions of data, and I can just see this in this particular radiographic chart. And you can see that in the control, the lower right quadrant, the green, is again that functionality of the mitochondria of freshly harvested. And you can see how bright and vibrant and bold that is. And compare that to again, to the custodial and the Del Nido, you can see the difference. And the red upper left quadrant, I'm sorry, the red is the percentage of necrotic mitochondria, and the blue upper right quadrant is the late apoptosis. So visually, you can see a significant difference. And again, this is controlled in vitro. So later that year, he took that study a step further and decided to look at the long-term effect of redosing those two cardioplegia modalities, piggybacking off of that same study and looking at the mitochondrial integrity and viability. So mimicking what it would be like to have to give a second dose. And we all know what the effects of redosing on the heart is. Every time we do that, we increase the interleukin-6 levels and we increase the syndicin-1 levels and all the negatives that happen every time we give a dose of cardioplegia. And so again, at the bottom, you can see trying to mimic an 80-kilogram patient on bypass needing 2 doses of cardioplegia. He at baseline was 37 degrees and drew a sample there, and then cooled the samples to 32 degrees. And at the 2-hour mark, drew a sample. So just at the 2-hour mark of protection, drawing a sample, rewarming the cells, and then taking another sample at 12 hours this time instead of 6. So doubling, and you can see all the the different red and green cell trackers that we talked about in the previous slides, you can see a significant difference in the 2 hour redosing point and the 12-hour late evaluation as compared to the Delnito group. All of them have clinical significance in the differences between the two. So in a redosing scenario, you saw that they were a little more similar in just a single dose. Redosing has more of a negative effect. So this study clearly shows the negative effects of giving a second dose of cardioplegia. So in conclusion of that particular study showed that custodial HTK was significantly better in protecting the mitochondrial function as compared to Delnito cardioplegia. And then finally, Dr. Ganaydin, this was just presented at ISHLT this year, 2025. He presented this work, and this was looking at the long-term effects of cold storage solutions. And you saw at the beginning of my talk today, looking at the effects of cold storage solutions and how important a role it plays in the mitochondria and its viability. So he decided to take on a study and look at the differences between custodial HTK, University of Wisconsin solution, and Celsior. And one observation that I can make as a clinician and can be fairly obvious is that there's not as much of a significant difference in these solutions as opposed to the cardioplegic solutions between custodial HTK and Delnito. And this makes sense to me as a clinician because these are preservation solutions that should have a substrate that helps protect the organs, and so they should be closer. But when you look at the data, and again visually, you can see on the in the graphs located on the right, the bolder and darker that the scan is, the less functional and the less survivability. So the red is the survivability and the blue is the functionality of the mitochondria as compared to custodial. You can see that the University of Wisconsin's and Celsior has less functionality and less survivability, but it is indeed a lot closer in this particular study than the previous cardioplegia studies. But again, this is early work just presented this year, and so much more work needs to be done. And so the takeaway from all of those studies is that there's still so much more to do. This is early, very early work. I'm very excited that I was able to present that to you. And this is where I see this heading in our field and where we as clinicians can have the greatest impact, and that's in organ donors. And so right here in the traditional DBD donors, the cold preservation solutions that we use can influence the outcomes of the patient, and maybe we can start looking at that on that cellular level and finally come up with a common solution that we can all agree has the best performance and produces the greatest outcome data. And then here in the DCDs that we're obviously seeing so much of now because of the onset of NRP, and thanks to all the perfusionists out there who works hard, and I know these are challenging cases but are doing great work. This is where we also can impact the outcomes of organ preservation and looking at it from the outcomes from a cellular level and not just typical indicators that I expressed early in the talk. Because really we create an ischemic reperfusion injury right off the bat, even before we get them on NRP or before we retrieve organs. So to really have, identify which solution protects the heart or the liver and kidneys for that matter, is so important. And that's where I see this work going, and not just looking at, the traditional outcome data that so many factors can influence the variability of those outcomes. And with that, I'll stop sharing my screen and I will take some questions, and thank you for your time. And
Thanks so much, Bill. So the first question is from Leon Stitchka. Any issues with having to go back on bypass a second time and then having to give a second dose of HTK?
that's a fantastic question. So those particular studies that I referenced didn't indicate any type of reperfusion and then reischemia. That particular study that showed the second dose was just assuming constant ischemia. So I think that's something that would warrant an investigation. So from a mitochondrial level and from understanding that particular study, my answer would obviously be no, because that wasn't really tested. From a clinical application and from experience, because I've got a fair amount of experience with custodial, the heart typically reacts the same when we take the clamp off post ischemia, whether we've given a dose, re-exposed and reanimated the heart, and then, had to go back on, had to reclamp and give another dose and reanimate. So, in my clinical experience, I haven't seen a difference, but that's a great question, and probably something that needs to be addressed in the lab and then maybe some clinical studies.
Oh, thank you. Next one from Craig Peterson. Very nice presentation. Thank you for sharing. There's been a number of studies that compare AFib rates among CABG patients with numerous preservation techniques. How does the mitochondrial preservation relate to AFib rates, as this is still the number one cause of post-op complications?
Man, I love that question. And this one's going to be even more challenging to answer, to be totally honest with you, because a lot of that outcome data, you can see that there are other uh, factors that can influence postoperative AFib that are outside of myocardial protection. But I will say that when you just isolate myocardial protection in a lot of the work that Gneiden did, and some of the work that I'm seeing out of other groups that have large prospective studies. If you do isolate the type of cardioplegia you use, you will see changes in. So I have no doubt that there is an effect, but I can't really quantify what that effect would be without looking at some more hard data. But that's a great question. I think I'm going to take that one back and do some more research.
Very good. Okay, another question we have, how important is the difference between HTK and Del Nido for cross clamps under 2 hours? Most of the data shown seems to support HTK for longer term preservation.
Yeah, it has, and I'll reference a paper that just came out that suggested just that the shorter the cross clamp time, the the more equal the results can be between the Del Nido and the custodial HTK arms. So that typically in shorter cross clamps, but these were referencing cross clamp times that were 60 minutes or less and not 2 hours, because typically if you've got a cross clamp time of 2 hours and you're using Del Nido, if you're not redosing at some point in that 2 hours, you're doing a disservice to that patient, and that heart, I can say confidently, is not going to function nearly as well as if you utilized custodial HTK in a single dose fashion. You definitely have to give a second dose, and we know that giving more than one dose of cardioplegia increases the mortality and morbidity of the patient. We see it in the data. The data is there to back that up. Does that answer the question? I think.
I think so. Yeah, I mean, I think that's it. that we can. Um, all right, we have what it looks like so far, one more question and then a couple of nice comments. Can you give blood cardioplegia after a Del Nido arrest for a short cross clamp extension?
For sure you can. And the reason you can is because the mechanism of arrest is identical. They're both extracellular. So you certainly can do that. But I will tell you that if you do that, you'll have to abide by the rules of protection with blood cardioplegia, and that's make sure you redose again 15 to 20 minutes into that and not take it out because really the what Del Nido is doing is just kind of decreasing the energy uptake. And so that's giving that additional advantage of waiting and not having to give a dose. But since you don't have lidocaine in that second dose, you're not decreasing the energy requirements. You're just solely relying on the buffering capacity of the blood to protect the heart, and that's going to break down quickly. So that would be my recommendation.
Very good. Um, so there's an anonymous attendee submitted another question. It says Vanderbilt's recent success with new procurement technique and solution for DCD hearts. Have you seen this process? And there's a link with it. So I
Mhm.
don't know that we'll
So
be able to address that right away unless you know what they're talking about.
I do know.
Okay, good.
I stay on top of what's happening in the cardiac and transplant world. So what they're doing is, I will tell you, I'll paraphrase, it's unregulated and it's experimental and it's being used in clinical settings. And so I can't I can't really comment on the success or efficacy of what they're doing, but they're essentially preserving the heart's um, off-label with an unregulated solution. And I really don't want to comment positively or negatively about that process because in my mind, it's it hasn't been really proven. This is all experimental practice, and we'll see where it goes.
Sounds good. Um, I will give it like 30 more seconds on the questions. I don't see any new ones coming in. We had a couple nice comments, a couple folks just saying what an awesome presentation it was, Bill. So we appreciate
Awesome.
that. And
Again, and I kind of expected that because A, this is fairly new. So it's not something we're accustomed to looking at. We're accustomed to looking at all of the factors that influence the post-operative outcomes. We're not really, used to looking at what we're doing from a cellular level, and it's really not even being done yet clinically. So this is all animal and in vitro. So you know, I do see that, science moves fast, just like technology. And I see that this will gain momentum. We will have more information. And I could see me giving this talk a year from now, and we're talking about, a new pilot study taking a look at this clinically. So I could easily see that coming.
we did actually get one more question as you were commenting. What measurements of electrolytes are optimal for mitochondrial protection?
Awesome. Man, this is I had no doubt it was going to be a smart audience. I actually do not know the answer to that question. So, again, just like you guys, I'm still learning and evolving, and that's something I'm going to take a note on. And I will try and if I get whomever asked that question, I will get an answer after I do some research.
Came from Maureen Gray, by the way.
Oh, great.
Because I could see, yeah, I could see her name. Oh, she's now, she says specifically magnesium.
Awesome question. I do not know how it optimally what the optimal magnesium level is and preserving them. But I will absolutely find out.
And then we got another one. What is the best speed to deliver the solution to the patient for optimal protection? For example, because of its mechanism of action, do you see it taking longer than a Del Nido or high K solution to reach arrest of the heart?
So typically, when you're utilizing custodial for arrest and for protecting the heart, it has enough potassium in there to um, to act as an extracellular solution. So that will cause the initial arrest. But then it's the sodium depletion, the intracellular portion of that, to maintain that arrest significant enough to where no matter what, you should never see electrical activity unless somehow that balance is interrupted. And so whether you've got washout or any of the other, you've lifted the heart and you've backwashed and changed the balance. So the answer to that question is definitely because of its intracellular nature, you have to deliver it slower so that you create a higher gradient so that you offload that sodium effectively. And so you reduce that sodium level enough to keep that heart arrested. But for the minute or two more in that arresting dose phase, it pays off significantly in the back end because you get minimum of 2 hours of uninterrupted repair as opposed to having to give 2 doses minimum of any other cardioplegic modality and add the time for giving a second or a third dose of cardioplegia and you will have saved a significant portion of time.
Yeah. A couple more just comments about individuals saying how much they learned and how much they realize they still have to learn, and thanking you for the presentation.
Awesome.
We will, Bill, of course, also make sure that um, that I provide you with a copy of the questions and such, so that you are, you're able to get back with people if you want to, if you're able to, or if you want to, and
Mhm.
it'll help, help all of us to kind of keep track of
Absolutely.
things. Um, so I think we've gotten to where we're probably at a good stopping point. I don't see any more questions. I do want to just let everyone know we will be having another webinar next month, November 19th, 5:30 p.m. Eastern again, and it will be an informational session on Organox, which is very interesting that I ended up relating these two. But
Yeah,
yeah, Leana Varvella from Organox will be speaking to us next month, and so we can look into that. If you have any questions and you want to prepare them ahead of time, my information and Bill's is on the screen. If you want to reach out directly with any additional questions or things like that. Otherwise, thank you all so much for your time tonight. And thank you, Bill, for a wonderful presentation that brought about some really good discussions and, questions that people will walk away with and look into their own practice and see what they can do. So thank you all
awesome.
for your time. Yeah.
Yeah,
Appreciate it.
thank you. Thank you so much. And I'm on LinkedIn as well. So if you've got a quick question you want to hit me with, you need a real-time answer, hit me up there or email me, whatever's convenient. But I appreciate everybody that took time to come listen to this talk tonight. Thank you so much.
All right. Thank you all. Thank you, Bill.
Okay.
Bye-bye.
Good night.
Good night.